Alrighty, so we got like 2 feet of snow yesterday. There's like no labs, so I thought might as well show you some terminal stuff while I work on my own stuff. Sounds good? Sounds good. Okay, so what I need to do is I need to get files set up for the Manhattan plot I need to do. Manhattan plot takes this sort of thing. I might as well show it here. Here we are. I need to get it into 4 columns. I need to get the chromosome. I need to get the base pair location. I need the SNP name, and then as well as the probability. I only have 2 of those things. But there's a good thing about it is that one of those columns I have, one of the 2 things I have, contains the other 2 things. So we're going to be doing some transformation. Alright, so first off, let's go into the actual file area. Love it. Okay. LS 20 by 200, and I want no. Let's just do a quick LS. All right. Influence values. That's it. Okay. So let's do a quick look at what these influence values look like. Head 20 by let's do 0. Influence values. Okay. So this is what I got. What I have there is the SNP name in that first column, and then its probability or importance for the machine learning model I did. So, good news is, for the SNP name, we have the chromosome and the base pair position. For probability, that's also fine. It's great. Awesome. So what we need to do is we need to transform that first column into giving us the additional 3 columns, or additional 2 columns. So, there's a number of ways we can do this. I am personally just going to be using whatever I come up right now, because I haven't planned this through. Alright, so a good idea when you're testing transformation is to always just use the head, because if you're working with lots of transformation, you're going to have lots of lines. Like, for example, let's do word count minus line 200 by 0 influence. That's 1,000 lines. I don't want to work with 1,000 lines. That's going to take up the entire terminal every single time. So, head. Awesome. Okay, so we can easily do a translate here. Let's translate the underscore towards there's a space. I think that's what it's eliminated by. Bam, there. Now we technically have the other one. What we can, the thing is, so this doesn't give us the exact output we need. What we can do is we can use a powerful tool called awk. Awk is great. Awk is like its own little, programming language and its thing. So let's get that tr, and then let's pipe that into awk. You're probably not going to be using awk for your final, but I love it. It's a very finicky thing. Let's see here. So I want to print the entire line. So that'd be print $0. Then I want to say 1, 2, 3. Because I just want to move it all together, I want to then print. Nope, need a double quotation marks, so also throw a fit. Okay, do that there. Then we're going to want to print the final line there, which you could do either, you could look at this and be like, okay, first column, second column, third column, so I could technically do $3. Or if I always want to make sure to print it off the last column, I could do $NF. Because in awk, because it's a sort of own programming language, it has specific variables and values with its own meaning. So kind of like their own little commands. But I do not need that. What I need is $1. Let's put another underscore in there, and then $2. Look at that. I got it. I got it. Oh, yeah, it's wonderful. It's great. There you go. So I just need to do this for all of them, which is fine by me. So what I would do is ls 20 what to do. Let's go influ. That's how many we got. These are all the files I have because the way I did my machine learning was it was a leave one out methodology. So you do all the samples for your training and you just leave one out and use that for the testing and you go through all of them. So since I had like 42 samples, I have 42 files. That's a lot of files. Now there's two ways I can kind of go about doing this for the Manhattan plot. One way I can do this is I can average the probability values because the same snips show up multiple times, or I can just keep them all together. I'm thinking I'm just keeping them all together initially because then I can sort them and end up getting the averages that way. So, first off, let's cat 20 by underscore inf because I want to get all of them out. Then I want to do this. And then I want to direct the output to 20 by 200 underscore clavet Manhattan. Did I spell Manhattan? How do you spell Manhattan? It's right over here. Manha. Okay, that's how I spell Manhattan. That does not look like a real word. Anyways, so Manhattan all dot txt. Ta-da! Word count minus line 20 clavet Manhattan. Yep, that sounds about right. Alright, so another tool you're going to be using a lot is the manual page. The manual page is your best friend in many instances. For example, let's look at man translate. Man translate has a number of options that make things easier for you, potentially. Like, for example, use the complement of set 1. The complement, I believe, is supposed to be using the opposite. I think? I haven't used it myself. You use this, minus D, to get your wonderful, delete the characters. Do not translate. Just get rid of them. Bad. Gone. No good. You also have this, squeeze. This is really good when you're dealing with, say, try output from certain programs. This squeezing option. Let's actually use it for a bit. Let's do that. Clear it up. Let's get our good old friend from lab exercise for PS. So PXAXU. Wow, that's a lot of information. That's a lot of data. That's a lot. How much is it actually? I'm curious. That's too much. I don't like that. Not a fan of that. So, if we were to technically do what we did for this lab exercise, we can pipe it into here, and then we can use something like grep just to find what we want. So let's look at my username. Ta-da! These are the processes. If we were to try and use cut for this, it will not work because these are inconsistently tab delimited right here. They're all only space delimited, but they're done by different amount. So this single space here would be its own column and whatnot. So if I say cut minus D, this to set the tab delimit, let's actually look at that man page. Let's look at man for cut. Delimiter. Use DL delim instead of tab for a field delimiter. That's why I'm using it. Then you also have your field operator here. Also print any line that contains no delimiter character unless the minus S option is specified. So what is the spec? Do not print lines not containing delimiters. Okay. Interesting. So, not really our need for here, but an interesting thing you might want to use in the future. Sorry, let's set the delimiter to a space, and let's do field 1. I want the first field. Okay, that works. I got the first field. Okay, I want the second field. Nothing. That's because it's doing the spaces here. I think if we go to 4, we got stuff. However, this one's blank. Because if you refer back to up here, we have the root here that appears. This was still found by grep because my name's right over here. So, 2 things we need to fix. First off, we need to make sure we get only the beginning that has my username. With this, you could do a grep with a symbol of the upper arrow. This will make it so it only appears if it's at the start of a line. There we go. We got no root over here whatsoever. Just my username. So, we have that. But now we can't really cut it, which is a bit of a pain in the butt. However, we gotta remember, we have our translate minus s, our squeeze operator. So, what we can do is we can translate all the spaces and squeeze them to a single space. That's still kind of messy to look at, and we know that cut takes in automatically a tab delimiter. So, let's just change them to all the spaces to a single tab. Ta-da! A lot easier. And then, if you go to cut, I could get the first field, I could get the fifth field, I could get the seventh field. Ta-da! And that's how you deal with some output that's very not nice. And yeah, I think that's it for this little demonstration. Okay, for our next little demonstration, we're going to deal with bash a little bit. But first things first, I'm going to make sure you all know what the heck I'm doing when it comes to doing this so fast. The arrow keys in the terminal are your friend. The up and down arrow goes through your history. So I'm going through this. So that's why I was doing it so fast if you were curious as to before. Going up goes all the way back, going down goes all the way to the front, and usually if you haven't typed anything, going all the way to the front gives you the blank line. I'm going to cd home just so it's a bit better. So, one way you can work with bash in the sense of, let me go to here. Let's look at the files here. Alright, so I showed this in Wednesday's tutorial. No one showed up to Friday's tutorial. If you see this, you probably shouldn't, because you didn't show up to Friday's tutorial. But, technically, I created a small script that tells you which lines are over a set limit. I'm going to tell you the process I did to create this, why I used what I used, and why the other alternatives did not work. So right, let's go with some simple scripts. So for here, I have my description on how you use it. The first input is the path to the file. The second input is the line length limit. So when it comes to bash and it comes to these functions, when you call a function, tail minus 5 simple. When you call a function like this, you put in values. So what I'm just doing here is I'm taking the input to the actual script and just funneling it directly to this function here. This is how you call it. Wonderful. So, for how this works is, the purpose of this one is to check the quality on a file to see if the line length based on the characters is greater than the given line length limit. Trailing white spaces are counted as characters. This is important because I wanted to specifically make sure it counted trailing white spaces as well as leading white spaces. So, the way it works is with awk, I'm going to take in the max value. So the way I would put it in is I'll put in, I would call bash simple scripts test.txt, and then I'll say 79, because I don't want to be greater than 80 lines, like it has with all your other scripts. So what awk does here is, remember, awk is its own sort of language. It has values that have significant meaning. For example here, I'm creating a variable called max, and I'm using the input of the character limit. It also has a specific value called length. This is the length of a line based on the characters. So just like how we have F and R, which is referring to the file number or the line number, like we're working on line 2 or line 3 or line 1, this is a way to tell us, okay, it's this line here specifically that's greater than. So basically, a simple if condition, if it's greater than, print over max characters in the file. You have to be careful when using awk in this sense, because normally when you want to use something in bash, you have to use the $sign to expand it. When it comes to awk, however, if you use the $sign, you're using it in the sense of you're trying to expand that specific column. You're probably not going to be using this. It's a bit more complicated, so just understand this is how it works. But it's different from bash. Bash will throw a hissy fit if you do something like this. But anyways, so this is what we're doing. We get that to output, and it's like, great, okay, awesome. Let's see it in action. Let's do a quick cat of our test.txt. Okay, so we have a bunch of leading spaces here, a bunch of characters, and it's not listed here, but we do have trailing spaces. We can tell we have trailing spaces by doing wc minus L with our test.txt, and it'll tell us what the longest line is. Our longest line is 121 characters, because this is very much obviously not 121 lines. If you want to double check, go man wc, you can see, okay, print the character counts, this is for the whole file, print the new line counts, again for the whole file, print the maximum width display with capital L, but it also is max line length. So there we go. We now know what the max line length is. You can also print the word count and whatnot, but that's it. So technically, this alone will tell you, okay, we have some ones that are longer than what is recommended and demanded of us for, say, the assignments or whatnot. Problem is, it doesn't tell you which one, and it does not tell you if there's any more. It just tells you the max. So what you would be doing is you would be searching through it manually, being like, okay, where is it too long? And it's like, it's a pain in the butt. It's a pain in the butt. You don't want to do that. You want it simple. We're computer scientists. We like things to be simple. We like things to be easy. We like to be lazy. And in order to be lazy, we have to be smart about it. So, let's quickly just test this out. Simple script. Let's do our test.txt. And then do, say, 79. There we go. We have 1, 2, 3, 4, 5 lines that are over our 80 character limit. So, we got line 10, we got line 11, we got line 4, we got lines 15, and we have line 16. So let's do head. Automatically it does 10, but it's still be good to do it. So let's do a test dot, and then let's do tail minus 1. This is the first one that's greater than it. This alone probably isn't enough here, but there's probably a bunch of trailing white space we don't see. So there you go, you could go and you can edit and be like, alright, let's go vim our test.txt. Let's go all the way up here. Let's go into insert. You can also see what line you are down here. So this is line 10. Let's go to the end. Yep, 97. Oops. Did not mean to do that. But what the? Huh? Oh my god. No. I just want to quit. I just want to quit. Why are you like this to me? I love programming. I love when things just does not want to work. I just want to quit. It won't let me quit. Yeah, I don't want any rights since last change. Fine. Right, then quit. Good grief. Anyways, there are supposed to be spaces in that. Do not know why there's no spaces in that. Because when you go to the end of a line, should have spaces. So let's go back and see our word count text. There we go. Now it's counting spaces. Don't know why the spaces were removed. Maybe I transformed it since I last time looked at it. We go back into it. Oh yeah, there's our spaces. Go to the end. Oh, there's spaces there. Great. Awesome. So let's make sure that the first line also has spaces. Near all the way over here. There we go. Now let's run the file again. There we go. It sees the spaces. It's like, oh no, there's spaces here. Not good. So, little misstep issue happening. Done. Okay. So, I thought personally, why not use cat? Like, I was trying to do this without awk. But I realized it's not possible based on how I was doing it. And I'll show you why. Let's do a quick clear. When it comes to using cat and awk and arrays and bash, there's one thing you need to know is that spaces, no matter how many there are your delimiters. For example, let's do PSAXU and just get ahead of that. So we have this. Say we want to put this as a array or try to take it as input for another thing. What we can do is we can do this followed by this. Then we can assign it to say, let's do a variable called temp. We do echo temp, we get the whole thing. But notice how it's structured. It's done like an array. If you actually look in your textbook, when it comes to doing arrays in bash, you'll see something similar to this, but it'll only show zeros as their example. But this is structured as an array. But since it's only printed out in one line, it's technically not an array, but it's structured as one. So let's think here and wonder, what if, since we know this is what it's going to output as, if we were to put another curved brackets here, we would then make it into an array object for temp. Now let's try an echo temp. We're only getting the first one because it's now a proper array. It's just not one thing where all the spaces were squeezed together and made into a single delimiter. It's all one single thing. In that case, but now it's properly delimited and made into an array. To go through an array, you need to use your fancy curly brackets. And then your square brackets, and then you could do like say 2. I want the second one to pop up. That's CPU. So this is 0, this is 1, this is 2. If you want to cycle through them, you could do an @ sign or the asterisk sign, the star. One thing we can do that's very interesting and nice, I will show you here, is that if you do echo -e, it's going to actually look at that. Let's look at man echo. If you do echo -e, you interpret / escapes, which is good because we want to, for this example, show you new line. So let's do new line. So we're doing all of them, and then no. Right, I won't be able to do it here. But if we do a loop, let's clear a bit. For I and if you want to actually properly loop through it, you would have to treat it as an array. So you have to expand it as an array. So temp @ do echo $, curly brackets, temp, or actually no, we just have to do echo I. And actually we won't even need the new line thing. Done. Now it's all on a single lines. The reason why this would not work well, because I was trying to do something similar. I was doing cat test.txt. I was going to do basically for I in this, do word count minus L, done. Yeah. I would still need to do this. You terrible, terrible person. How dare you do this to me? Okay. Let's assign temp to... What the... Is... I don't want it as a directory. Oh my goodness. Cat. Nope. Give me a second. Cat test.txt. There we go. Then you want for I in... Let's just get this here. There we go. We can echo I. So we're getting it out. So this is what we're reading in. Let's try and do word count minus L, because that makes sense. We want to do the word count or character count per line, right? I am silly. I keep forgetting to do... echo I, and then pipe that into word count. So that's one line. So let's do it with the C character one. Notice how none of them actually include the white space. This is because when you do anything with array, it squeezes, concatenates all the white spaces, the blanks. So this is why I couldn't do the same, okay, tell me which lines are which length. It's just great to tell you which number of characters are not white space, but you lose information. Because there's a distinct thing in the sense that, remember how we had these on the same line? So let's just do a echo, and then cat test.txt. It's different. It's been transformed in a way we don't want it to. Specifically, the white space here, gone when it comes to the previous one. No white space here. When it comes to the equal signs, these are treated as their own lines now, which is not what we want. So that is why I used oct instead of wc minus L. And I think that'll be enough for this demonstration. So the main takeaway from this is transformation will happen, and you may not be aware of it unless you know the tools or you constantly check through each step of the pipeline process. Sometimes these transformations are great. It's wonderful. You may just want to take everything in an array and not worry about it, especially if you transform it all ahead of time. Like for lab exercise 3, when it came to this PCX, if you transform it ahead of time within the little bracket to make sure you only get this column, and then you remove the head, then great, you're able to loop through that very easily. In cases where you don't want that, you're going to have to find another avenue when it comes to dealing with arrays in Bash.